Okay, so I'm continuing to work through my old final exam from 2007. I've already done the first problem, and let's just jump to the second problem and see if I'm a terrible person or not. Okay, so I'm going to turn off this camera. So here we have, and I'll try to use the space provided, but if I run out like I did there and I didn't even know it. 100 kilogram space probe is at rest in deep space away from any other objects. Okay, so there's no force on it. Oh, a rocket thruster of a probe is on the probe is turned on for 20 seconds, so delta T equals 20 seconds. Let's just write this down. M equals 100 kilograms. And it provides a thrust of F equals 200 newtons. And so I wrote that as a scalar because I don't know the direction. It just says how fast is the probe after 20 seconds. Okay, this is a pretty easy problem. If I think of force and I think of time, I think of momentum principle. This is a one-dimensional momentum principle, but it says in one dimension, F net x equals delta px over delta t. And so these are components because momentum is actually a vector. So px is mvx. So I know that it's at rest, so the initial momentum is 0. And I want to find the final momentum. So if I multiply both sides by delta t, and I get F net x delta t equals P2x minus P1x. What the heck was that? And then if I add that to both sides, I get P2x equals P1x plus F net x delta t. So that's 0, and this is mv. So I can use this to solve for v2x. v2x equals F net x delta t over m. And now I just need to put in my values. So let's skip over to Python here because I'm using Python. That's what I like. And this is my stuff from the last problem. I'm going to delete that. M equals 100. F equals 200. dt equals 20. Yep. And let's just say that's fine. So V2 equals F times dt divided by m. Print V2. I'll just print. I'm not even going to write out the thing. So 40 meters per second. So that's what I get. Let's just jump back over here to the paper. So I said 40. Could you do this another way? Yeah, you could. If I said F net equals x equals max, I could solve for the acceleration and then use the kinematic equation v2 equals v1 plus a delta t, and I'd get the same thing. But again, it's not too terribly difficult of a problem. I think it's straightforward. I like this problem. I kind of wish it would have had vectors, but if you know what you're doing, you can finish this without too much work. So overall, this one's, I think, a little bit better problem than the previous one. Okay, so I'll do another problem. It'll be in the next video, so I'm stopping here.